can skip 5 classes, absolutely no problem. Good, thank you for the waiting. Now, questions about the assignment, Doherty calculator. Did everybody submit? Yeah, cool, right? Super. Question, no? I didn't call you, Nura. Okay, after the class, Nura. Anybody has a question about the submission for the Doherty calculator? Wonderful. Okay, and the next submission we have is the Fitts law, verification of the Fitts law with the Doherty calculator, right? So the other day we saw a presentation about Fitts law, and we saw the Apple calculator, and we saw how they try to, you know, maximize or minimize the Fitts law delay, right? Or difficulty index. So the next challenge is to have 2 calculators with different button sizes or different buttons apart, or if you don't like calculators, you can do a small game with 2 buttons, right? JavaScript or calculator Java or whatever. Python as well is good. And see if you can do it. You can use Scratch as well to do this game and measure the delay and then plot it and see if we can verify that Fitts law is real or it's a fake news. What do you think? Right, because these days, you know, you don't know what's fake news and what's real, right? So it's better to verify. Are you with me? Good, great. Questions about that, the assignment? Due date is 9/5, so yeah, you have like what, 4 more days. If you need more time, it can be extended, but I think I don't want you to spend too much time. Just spend two hours doing this. 1 hour, 2 hours max. Shouldn't take much more. Yeah. It's today. The Doherty is today. The Fitts law is in a few days. Yes. Okay. Good. 11th. Right. Anyway, deadlines are for you to motivate yourself. If you miss a deadline, it's okay. You miss like a small amount of grade, but not much. You can submit as many times as you want. You can ask for feedback. Where to ask for feedback? Email or Slack? Which one? That is correct. Slack. Mohamed Grace asked if the syllabus is on Slack. Can somebody answer him? Yes, it is on Slack. How do you find the syllabus? So you would go to Slack and you would look for the Dropbox. Like here. Look at me, Dropbox. And then here is the Dropbox. And here you have the syllabus, right? We use this one. This is for the other students. And then here you have all the teaching materials about Fitts law, and I add everything here. This is from previous years, so don't watch it yet. Okay, so this is what you can read so far. This is a very good paper on Fitts law. If you're super interested, you can read it, but it's not going to enter in the exam. It's a historical paper. These are the slides from Hicks law. All right, good. Sounds good. And you have previous exams here. Hey, come back. Previous exams will appear. Here. Right. So previous exams will appear. They are here. Teaching material, assessment instruments, previous exams. You can check it out. And for the other years as well, check it out. And so, right. Good. We'll do mock-up exams as well. Great. Questions? Good. I also added a poll on Slack that you will love. So yeah, Slack for feedback. Okay, so it's nice if you share your homework here so everybody can see the feedback. So it's useful for everybody, everybody learns. Yeah, so if you are very shy, send me a private message, but really if it's a question that somebody can benefit and feedback on a homework, everybody can benefit. Share it in general, it's much better. You can receive feedback from your peers and so on. I also added this poll here. Can you see it? It's nice if you answer it. It's completely anonymous. And so 10 is high score and 1 is low score. This is to calculate the net promoter score. So 1 means that you would never recommend this course to anybody. 10 means that you would recommend it 100%. Sounds good? Great, wonderful. This helps us make the class more interesting or find things. Yeah. Any suggestions? It's completely anonymous, so just be very important that you honest, and it's anonymous, so it doesn't matter what you say. Like 10 means that you will recommend it like 100%. It's like one of the 10 top 5 courses that you ever had, right? So is it really 10 or maybe it's 90%, right? So sounds good. And 1 means that you would never, ever, ever, ever recommend it to anybody, okay? So most of the people score 9, 8, 7, 6, 5, 10, like it's a bell curve here, and unless the course is very bad. Then this score is used for brands and everything, so it's used in many places. Right, good. So no questions. Okay, everybody clear with the Fitts law and the formula, the log and all that stuff? Yes, I'll send you some exercises to do. Let's see if I can. Yes, okay. Mariam, which book are you referring to? The textbook, or there are many books about UX? In the Dropbox, there are some books that we will use. Yes. Right, cool, good. Okay, send me a screenshot because I'm not sure which book you see and if it's the same I see. Okay, so if you can send me a screenshot on Slack, that'd be nice. Someone. Yeah, okay, good. Okay, I will check it later. Super awesome. At the moment, we will not use girl assembly. Okay, good. Right. Let's see. Yeah, okay, good. So today we will see the third law of UX, and this law is called Hicks law. Does anybody know Hicks law? It's called Hicks law. Okay. So we will watch a small let's see, video. And first, let's look at this formula here. So this is Hicks law. Okay, so Hicks law is about measuring the response time when somebody has to choose between more than one option. This means menus, right? So here I have 8 options, 10 options here. And here I have more options, right? And here I have more options. And here I have some options, right? So how much time will it take me to choose, to make a decision? So there is a law for that, and it's called Hicks law. And this is the formula. The response time is going to be a constant that depends on the task. If it's playing some card game, choosing some cards, or if it's a computer menu, it's different. A depends on that. Then you have this constant here, which is a constant that depends on the type of exercise. And then you have a log 2, and then this is the number of choices. So for example, it means that 2 choices, 4 choices, 8 choices, 16 choices, right? it's the log 2 of that. So if I have double the amount of choices, the time grows linearly, right? So if I double the amount of choices, for example, from 32 choices to 64 choices, yeah, so even though it's double the amount, I just grow the time a little bit more. Sounds good? And this is expressed very well in this chart, right? So for example, if this is number 2, for example, 2 options here, and 4 options is going to be here, right? So I don't double the amount of time it takes to make a choice. It's less, and this less is the log 2, the logarithm. So it means that doubling the amount of options doesn't increase the time double. It's just less than double, less than linear growth. And the same, if I reduce the amount of options in a menu, I don't reduce the time by half, right? Because we have the constant and we have the logarithm. So if I reduce, for example, from here maybe 64 choices to half, 32 choices, I didn't reduce by half, right? I just reduced 10%, right? So that's what it means. And this is important when you show a menu to a human. So you might want to think, okay, how many options should I use? Or should I nest menus, right? Or is it better to put just one big menu, right? So these are design decisions that you want to optimize, and Hicks law can help you optimize. This comes from human factors again. It came out at the same time as Fitts law. How does this look in reality? So here you have data, real data from the Hicks law, right? So this is for one participant in an experiment, and this is the data they got. This is milliseconds here. Mean correct reaction time. So the mean time it gets to for the person to push the right button or to choose the right menu option from the menu. So you can see different people have different reaction times, but more or less they all follow a logarithmic curve. Do you see that? Yeah. So this is how a real experiment. It's quite interesting. Wonderful. And here you have places where you can apply this. And so, for example, this is a typical experiment. So you can use it for, okay, how many, for example, you have a supermarket. Should you put a lot of products on display or not too many products on display? If you put a lot of products, people take more time to think about it. So this has implications on how many people will buy your product, right? Here's an important keyword. It's called cart sorting. So if you look at menus here, so when you or the designer of the programmer decides to make menus, no? So you see here we have like, this is the menu, and we have 1, 2, 3, 4, 5, 6, 7, 8 drop-down lists, and then we have sublists, right? So the way to organize or cluster or classify menu items, how do you classify them in groups, right? So the way to do this is called cart sorting. It's an exercise where each menu item you print on a card, you put them on a table, and then you let users group them as logically as possible. And that's how you can make menus that look logical to a user's. Cart sorting is an exercise. If you take the class usability, foundations of usability, SWEP 654, which is the next class after this one, you will learn about applying this to design good menus that people love. Right, so that's it for Hicks law. Let's watch one of our wonderful videos from Nielsen Institute. Fitts law. Here it is, what it is. Here you go. Right, and I need to cut the presentation, and I need to stop the sharing and reshare again because the user interface. And I click on share audio, and let's go. Can you see the screen? Wonderful. I guess that's a yes. It'd be nice if the sound of the doop 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 was changing. If it was a yes, it would say beep beep, and if it was a no, it would say pop pop, right? That would be Nura. Nura, you don't see the sound? Okay, wait. What about now?
Would you believe it if I told you that a menu with 20...
Is that a yes? Can you hear the sound? Okay, good. Let's watch it. Oh, by the way, do you see the logo? It says NN/G. Yeah. So this logo, this video, was made by NN Group. Who's this guy? It's good that you know at least this. Yes. So who is NN Group? So if you Google it, Nielsen Norman Group. Anybody hear this word before? Nielsen ratings. Yeah, very good, Fatima. So Nielsen is a company that makes phone calls or surveys to consumers, and then the consumers answer. And companies like Coca-Cola, Procter & Gamble, Carrefour, when they want to know what people think about them, the brand, they go to Nielsen, and Nielsen maybe calls 1,000 people in whole country, and then they come back with the results. They also do a lot of usability studies, how to improve the sales in the supermarket by arranging things different, how to improve the sales in the website, and so on. But it's a user, what we call user research company. It's a bit related to human-computer interaction. And it's good that you know it. If you work in marketing, you definitely will know it. The other is One Kantar Group. They do the same thing. These people, they do qualitative studies. So for example, my friend works at Kantar. She's now interviewing Saudi women, and they ask them about some cream or something, why the sales are going down and so on. Sounds good? Nielsen and NG Group now. No. So yeah, if you end up working in consumer products, you'll hear about that. Right. All right, good. Wait.
30, even 50 options could be just as fast or even faster than a menu.
Okay.
Would you believe it if I told you that a menu with 20, 30, even 50 options could be just as fast or even faster than a menu with only 10 categories? It's pretty unexpected. Traditionally, we think of menus as being most efficient if there's fewer options to pick from. And don't get me wrong, in many cases, that's absolutely correct. But there are some rarer cases where it's actually acceptable to have a long list in a menu. Now, in order to reach that elite status of being a menu that's appropriate for many, many items, you have to satisfy two criteria. The first is that it has to be in order. So typically alphabetical order works pretty well. The second criteria, and here's where it gets more important, is that the list contain items that are known to the user. So it's a list of words and terms that the users know that exact meaning. They know that exact term. So think of, for example, a long list of brands or companies or TV shows or US states. If we were to picture that long list of US states and say we're looking for Pennsylvania, wherever the user's eye lands first, the user can adjust their gaze accordingly. And they can adjust their gaze because they know it's an ordered list and they know the name of the item that they're looking for. Pennsylvania will not be called by anything but Pennsylvania. So they can quickly skip over all of the other content, all of the other letters that aren't necessary. That's not what they're looking for. And that makes navigating a long list of 50 items really quite efficient. The reason we know this to be true is because of the Hick-Hyman law. Hick's law refers to the process of making a selection from a list. And the law says that the more items in a list, the longer it's going to take to make a selection. Not too surprising. But this very unique set of lists where there's an ordered list and all of the items in the list are known to the user, those two attributes combine to make for really efficient scanning. And therefore, even if you have a very long list, users can be very efficient with it. So you can use Hick's law and this understanding if you're ever faced with the decision of whether or not to include a really long list of menu items. And you might find that if it in fact satisfies those two criteria, it's actually okay and your users will be quite efficient with it. So consider Hick's law if it applies to you.
Wonderful. Okay, good. Got it. Sounds good to you. Questions about Hick's law? Let's see. Right. So does it mean, so if you have a list of 32 items and you increase it, you double it to 64, the time that it will take a user to select the correct item will not be double. It will just increase logarithmically, right? So calculator. So applying Hick's law, you could calculate the logarithm of 2. And for this, I need the. Can somebody tell me how much is the logarithm of 2? Oh, here it is, right? 6v8, what's that? No, the logarithm of 2, how much is that? I need log 2. Oh, I don't find it here, they don't have it. So it will increase by logarithm of 2 only. Not in base 2, in base. Okay, yeah, let's do this properly. So this, okay, yeah, let's do this question for you guys now. So let's imagine that, maybe let's do this in Miro. Can you come to Miro? Yeah. Let's do this small exercise here. Hicks law, right? So Hicks law, if you come here, A plus the reaction time, A plus B, and then we set log base 2 of the number of choices, right? So let's imagine, I need a table here now. No, small table. Table, please. Tables here. Right. So I'm gonna, wait, this table is very big. So I'm just gonna put a small table. Tables here are so bad, right? Let's do a small thing. Okay, here, very good. Very good, now it's a bit better. Okay, so how much is the reaction time going to be? Okay, if let's say that the reaction time, typical exam question, the reaction time is 1,000 milliseconds with n equal 16 choices. Okay, and A and B, we know they are constant for the same experiment, right? So imagine your boss comes and says, oh, you are a human-computer interface expert, right? So can you tell me what will happen if we increase the choices to 32, right? So can you calculate that? Can you use a post-it to calculate using Hicks law and knowing that A and B don't change, right? So can you estimate a little bit how much will the reaction time increase if we double the number of choices? Anybody? Yep. Okay, how would you do it? right? So what we know is that 1000 milliseconds equal A plus B log 2 of 16, right? So how much is it going to be? A plus B log 2, 32. Estimate how much is it going to increase. And well, to make it a bit easier, let's say A is 300 milliseconds and B is, you can find out B if you know it, okay? Can you find out what will happen when you double the number of choices in this scenario? And this is a typical number for a computer menu. You know that A and B are constant in every experiment, right? So this could be the menu of here. Imagine that you have to choose cut and from the menu, and then you have to scan all the choices and then click here, right? So how would it work? So anybody? Yes, I give you 1 second, 1 minute. No? Yes. Dr. B, should the same, yes, A and B don't change, right? If you change the number of choices, A and B pretty constant, basically. We assume, oh yeah, sorry, I was on middle. I'm sorry. Oh, thank you. Sorry about that, so many screens. Share application screen here. Right, can you see share application screen? Middle here. Okay, good. So middle. So here's the formula of the Hicks law. Is this correct? Yeah. And so if I tell you, you know, for example, that the reaction time now is 1000 milliseconds with n equal, so put your post-its below here. Yes, thank you. Use post-its below to solve this. How would you solve it? And so, right? And your boss comes and says, hey, what will happen if we increase, what happens if we increase n to 32? What happens, right? So what happens? And I tell you that A is about 300 milliseconds. Right? So can you tell me what will be the new response time? Simon Kedarota, okay, can you explain how you did that? Or anybody? First correct answer gets a bonus point. Okay, ready? Yes.
Okay, should I explain? So,
Simon, please explain the formula. Type it.
all right.
On your post-it. I'll make a post-it for you. Sounds good? It's green color. Like the fields of Rwanda. Simon, yeah, type on the, yeah, type, yes. Okay, tell us what you did, Simon.
Okay,
Simon,
can you hear me, guys?
Yeah, now yes. Start.
Okay, good. So, like from the given formula, we have 1000, which is equals A is already given, so 300 plus, and we go for B, and we have logarithm of 16. That's already 4, so we can just multiply here times 4. And from this equation, we can simplify and we'll get B, which is 175. And after that, we can find, we can look for the new equation, which is x equals A, that was 300, and plus B, 175. And then multiply with logarithm of 32 in base 5, I mean in base 2, which is 5. 32, and yes. The result, here we go, 75.
Very good. Yeah, so 175. Is it double the time? No, it's not double. It's not 2000 milliseconds. It's just a little bit more. Sounds good? So it's a very good example, right? So if it's acceptable for you, and now think about the Doherty threshold, right? Like, how far away are you from the Doherty threshold? Is it okay? Or is it better to have two menus, but then you have two more menus, right? So think about that, what's optimal overall, right, for the user experience. So that's it. Yeah, sounds good. So that's a Hicks law. Yeah, good, wonderful. All right, so if that's it for today, if there are no more questions, that is the third law of human-computer interaction. Right, good, wonderful. Let's see. Okay, can you please answer the poll on Slack if you have time? Yes, it really helps us, like, be honest. Any more questions? Now, remember the protocol of the class. You have a question, Slack. If I don't reply on Slack, then you send me an email. Not the opposite. Sounds good. And then if I don't reply the email, you can WhatsApp me or you can call me. Yes? Okay, good. So we'll stop here if there are no questions. Anybody has a question? No? Okay, I will. You may now leave the class and remember to submit your assignment 1 and 2 before the deadline. And remember, the goal is that you get an A in all the assignments. I totally recommend you do the assignments because it's an easy way to score points. Yes? Good. Oops. Excellent. We should be thinking of doing a exam quiz in next week, maybe. You happy with that? I will put a poll on Slack, so you choose the date that you like, okay? Right. Any more questions? Questions? Just follow the instructions. I think the instructions are pretty clear, and they ask, let's see, do they say the format? Right, so if you can submit just text file is really good. So you will not get grades here for making a beautiful PDF file, right? So here's the thing, like when I grade your homework, I have to grade it inside the Blackboard. So for me, the fastest thing is that you submit text file and links, right? So if you're, for example, if your calculator is on GitHub or Heroku, put that as a link, right, to the GitHub. If you have an Excel table, submit it. PDF is fine. Text file, just keep it simple. You know, you don't get grades here for making beautiful Helvetica 1.4 font and so on. Yes, sounds good. Just keep it simple and to the point. Salama, if you say that, dude, you can submit a video if you feel so adventurous. Do it. I think it's really, really nice. If you submit a video, but to the point, okay? Don't add long introductions and loud background music, okay? Just go to the point, make a screencast, 20 seconds, TikTok style, you know what I mean? Yes, go to the point. Yes, show, like, not 1 minute video, 20 seconds should be enough to show that you did the work and the main results. Yes. It's easy to make a long video. It's very hard to make a short video with the same information. Docs is also fine. Text file is fine, but docs, PDF, all this is okay. It's fine. But what I'm saying is that don't spend too much time making a headline and a title and this. Just keep it simple. Yes, just do what they ask you here. It's like paragraph explaining what you did, a link to the code, or a video, yeah, optional Excel file,